Okay, this is geometry class for this week. We're going to start with the projects, and in this particular class, because we had just a few, I wanted more people to do projects, so each one is doing one separately. All right, Bennett, so if you'll start and introduce which problem you're working, and then you may talk about it.
I'm working on problem 12, page 294 of the text book, and to show that this equation is correct, you can just create a number for d, which is what I did. So if I made the square, so if the side, well, if the size of the square, or 5 actually, so it's a square, and so if you just do it the normal way, the easiest way, 5 times 25, so the area is going to be 25. So if you find d would be in this equation, it'd be like 7 and a decimal. It'd be 7 and a decimal would be d in this problem. And so if you took that and squared it, and because that's the equation, then you would get 50 and multiply that by 1/2, and then that's 25.
Okay. All right. So let's go back to our triangles. You have an isosceles triangle, isosceles right triangle, right? Okay, so in the case that you have right now, if you use the Pythagorean Theorem, because that's what this chapter is about, all right, what is the Pythagorean Theorem on your example? It says a squared plus b squared equals
c squared.
Or in this case, d squared, right? Okay, so what is a squared?
5.
All right, no, 5 squared.
5 squared.
All right, write it down. Write it down. All right. Plus 5 squared equals d squared. Okay, now, what happens when you add those two together? What do you get?
50.
50, okay. So, use the eraser. Where'd it go? Here it is. Okay. So, okay, now, so let's take and write 50 equals d squared. Because that's what he's got, right? I mean, that's what he told us. All right, now, the square root of both sides will get you d, right? Yes. So square root of 50, no, square root of 50. Right? To be accurate, the square root of 50 equals d. So write square root and put a 50 underneath it. All right, now, everybody agree with that so far? Okay, now, is there a perfect square in 50?
No.
Oh, yeah.
5.
5 times 5.
Oh.
So that's 5 times 5 times 2, right?
Yes.
So break the 50 in square root of 25 times square root of 2. Square root 25 times square root 2. No, times square root 2. All right, equals d. All right, everybody see that? Is that correct?
Yes.
All right, now, that means that you're going to have 5 times square root of 2.
So square root of 2, square root of 5, square root of 5?
No, be 5 for the square root of 25. Square root of 2 equals d. All right, so what you have in your example, right, is that what happened to the side of your 5? It was multiplied by square root of 2 to get the diagonal. See that?
Yes.
All right, so in that particular problem, what happens if you put an x where for the side? Put an x for the side.
For the side of the square?
Yeah, just put it when it comes back up. Whoa, what happened? Where'd it go? Over here. Disappeared. Oh man, I hate this. All right, let's go back to here. crazy today. All right, let me see here for a second. Okay, remember he had a rectangle, and this was D. Okay, if this is X, and this is X, then you're going to have X squared plus X squared equals D squared, which is going to be the square root of 2x equals D when you take square root of both sides. All right, now, this right here, what they said was, what happens, what's the length of that side?
5.
Don't use 5. They said it was D square root of 2, I think, right? That's what you're going to have to find out. But hang on just a second. Let me get that back up again.
I think if you zoom out, I think it's zoomed into
You think so?
That's on a PDF. Oh.
No.
The genius.
I am.
Okay, but I still.
Yeah, and the
And you gotta scroll down to the problem. I'm gonna go find the page again.
Thank you.
That was off of his case.
What was it? 90 what? 94?
94. Yes, sir.
Okay. I can't move my fingers here. See, now this isn't even working. Oh my. 92. Okay. All right, so the diagonal length is 1/2 of D squared. All right. So we've got square root of 2. Oh, I know why. I know why. Look at here. How many is this?
2.
So this is x squared. All right, write 2x squared right there. 2x squared equals d squared. All right, divide by 2. Divide this by 2, you get x squared. And divide this by 2, and what do you get? Put divided by 2.
You get D squared. Divided by 2.
Okay? All right. Okay, good. All right. Thank you. All right, good. So, all right, see, one of the things that you're supposed to be doing in this section is using the Pythagorean Theorem. Okay, who wants to go next? All right, good. Caitlin, what number did you have? What page?
Number 6 on page 293.
73.
93.
93. No, that's even better. Number 7. Oh, a lot of words. Okay.
Yeah, a lot of yours.
All right. Go
Number
ahead.
6.
Number 6. So this is 7. All right. Less words.
Okay, so I was a little confused on mine, but basically it says give an example of a rectangle, the length of whose sides and diagonals are all positive integers. And then the second part says, can you find a square, the length of whose sides and diagonals are all positive integers. So I basically looked up the rule that a rectangle is a square, but a square can be a rectangle. And so I decided to go with B first before A. And no, A before B. I need the marker.
Sure. It should be right there.
So if we have a rectangle right here, and we have the length of 28 with the 14, and we make a diagonal either way, we have our right angles here, and then we have these positive numbers, but it's not possible to make this right here positive.
Well,
Because
okay.
everything together would
Right.
be 15.65, and that's not.
Okay.
So,
All right. Okay. Now, are there any perfect square combinations that you know of. Like for instance, remember the triangle? What's the famous whole number triangle? That has sides of
3, 4, 5.
3. Okay, so change your sides instead of 14 and 28. Change it to 3 and 4. Now, what's the diagonal then? 3, 4, and 5, right? So the diagonals, the distance from your two boxes, the diagonal is now 5. Okay, double them all.
So we have 6 and 8.
6, 8, what will be the diagonal? 2 times 5 is 10, all right? Multiply each of those numbers by 3.
9 and 12.
Okay, so change them to 9 and 12. All right, here. Change them to 9 and 12. All right, now, give an example of a rectangle, all right, now, whose lengths of sides and diagonals are all positive integers. All right, now, so you have 12 and 9, now what will the diagonals be?
So 12 to this.
All right, what's the length of your diagonal now?
12.
No, that's the side, that's the bottom. The diagonal goes from the top to the bottom inside. All right, you see the triangle?
Mm-hmm.
Okay, you have two sides, 9, 12. That's 3 times 3, 4 times 3. The diagonal is
5.
times 3. 5 times 3.
Wait, I'm confused.
Okay, all right, a 3, 4, 5 right triangle is the smallest whole number triangle that you can have.
Uh-huh.
Okay, you just made a 3 point and you dilate it and made it 3 times as bigger.
Mm-hmm.
So the 3 side is now 3 times 3. Look at it. The 4 side is now 4 times 3. Then the diagonal will be 5 times 3.
Okay.
Which is how much?
15.
15. So your diagonal is 15. So put a 15 along for the diagonal. Okay. All right. So now she has created in 6A. She's created a rectangle that has lengths that are integers. Whole numbers, right?
Okay.
And also a diagonal that's an integer. And what Caitlin was telling us is that the one that she gave as an example, the diagonal is not an integer because the Pythagorean Theorem won't allow it to be.
Yeah.
Right? And so you can't pick just... Now, the second smallest triangle after 3, 4, 5 is 5, 12, 13. Right? So make another rectangle. And do 5, 12, and the diagonal will be 13. All right, now, you could double all of those.
Mm-hmm. So we have 25, or 24, 10, and
26, yeah. And so that otherwise you got what Caitlin was talking about is that your diagonal, because of the Pythagorean theorem, will not be a whole number unless you have, these are called Pythagorean triples. Because all 3 numbers are integers and they all work for Pythagorean theorem. Now then the question becomes, can you do that with a square?
yes.
How?
I mean,
All right.
unless you flip around like the rule that.
Okay. All right. So what you have to find is a squared plus a squared equals c squared. Okay. Draw a rectangle. I should draw a square. Okay. Okay. Now draw the rectangle in. Draw the diagonal in. Excuse me. Draw the diagonal. Okay. So one side is x. The other side is x. Okay. Now, when you square both of those, you'll get, and add them together, you'll get 2x squared, right? Mm-hmm. So the diagonal will be the square root of, now put it on the diagonal, will be the square root of 2x squared. Now, is it possible for there to be a value of x where the square root of it is going to be 2x squared?
Is it possible?
Is it possible? The only number that you could multiply that by would be the square root of 2.
Mm-hmm.
right? But the square root of 2 means that the x's won't be integers, they're going to be irrational. So the answer to B is there is not. Because the diagonal of a square is always going to be the square root of 2 times whatever the length of the side is. Because Pythagorean Theorem doesn't give you any other choice. All right, good. So first part she did right. Okay. Second part is talking about whether or not you can do with a square the same thing you can do with the rectangle. All right, good. Good job. Good job. Thank you for erasing that. Okay. All right. Who wants to go next? All right.
I'll just go.
Okay. All right. Which number?
It is number 11 on 294.
Okay.
I wasn't going to draw anything, but I guess we'll probably have to.
Yeah, that would. Yeah. Okay. Wait, which number are you doing?
Number 11.
11, okay.
Okay, so.
All right. Now, you sure that's 11?
I mean, I can try to.
All right, wait a minute. No, I'm saying that's not the same. Do you, which page number? That's chapter 6 you got, don't you?
Oh, this is from chapter 7.
Okay.
But I have to.
All right, go ahead. Go ahead.
I don't know. So I was actually like really confused about this. So, and when I first started doing it, I was going to use the Pythagorean Theorem.
Yeah.
But then when I was looking in chapter 7, I found something called the 30-60 triangle.
Mm-hmm.
And well, I'll start with the question. So the question is obviously a certain right triangle has an area equal to 42, and the length of the hypotenuse is the square root of 193. How long are the legs of this triangle? So when I was looking in chapter 7, I found the 30-60 triangle, or 30-60-90.
Okay.
And so then I started looking at that, and to find it, it says that the shorter leg is half as long as the hypotenuse, and the longer leg is the square root of 3 times the length of the shorter leg. So what I did to find it, which I don't know if this is right, is so the hypotenuse was S, and so S is the square root of 193, which was 14. So that's where I got that from. And then what you did is you would do S divided by 2, so 14 divided by 2, which is 7, and 7 is the opposite angle of 30.
Mm-hmm.
And then I did the square root of 3 divided by 2 times S, which would be times 14, and that equaled 12, which is the opposite of this 60-degree angle.
All right, except that the square root of 3 times the other side is going to be an irrational number. So it's not a whole number. It rounds to 12, but it's not a whole number. Okay, that was the part. Okay, all right, good. So all right, so you that was good. All right, now if you will, erase your numbers. And let's look at something here. Okay. All right, now because we don't know them. Let's call the side that you erased last H for height, and then put the other side as B for base. Okay, now, what is the area formula for that triangle?
1/2 B times H.
All right, write that down. 1/2 B times H. All right, and it equals 42. According to the, right?
Yes.
It equals 42. Okay? Now, the other one says the length of the hypotenuse is the square root of 93. Now, is that a perfect square?
No.
All right, so let's put square root of 93 for the hypotenuse. Just write square root of 93 on the hypotenuse.
It's 190.
193, I'm sorry. 193. Now, h squared plus b squared equals 193. Because a squared plus b squared equals c squared, right? So you can write h squared plus b squared equals 193. Okay, now what's h? To get h by itself, how do you move the half? How do you move the half on h? You multiply by 2, right?
Yes.
Okay, so that'll make that 84. And then to get rid of the b, I'm going to have to do divided by b. So h is 84 divided by b. If I replace the h with 84 divided by b, so underneath the h squared, write 84 divided by b. Now, square it. Put it in parentheses and square it. Plus b squared equals 193. All right, that is the equation that you have to solve to find b, and then you put that value back into the top equation and you find h. And then you will determine that h squared plus b squared will equal 193, and so the hypotenuse is the square root of 193. Okay, now that was a little bit harder problem than, but I like what you did in the fact you went back to the 30, 60, 90 right triangle, right? And in that case, the question is, square root of 193 is not an integer. It's an irrational number, and what you've been used to doing is been cutting them off, right, and rounding them, right? And so in this particular class, to round them would change it. And so if you use the exact one, then obviously the math is a lot harder, right? Okay, but good job. Good job. Okay. All right. All right, Casey, which one was yours? Now, do that again.
Column 20 on page 298.
20.
Yeah.
290. Here we go. Oh my.
I know, it's amazing. I don't know what Heron's formula is. See, I looked it up, but literally all it talked about was the Greek origins and how it worked. I couldn't find anything to solve that, so I wasn't sure what I was supposed to do for that. Like literally nothing I found. Like I found the stuff for it. I found
there's a formula that adds up the square root of the sides added up.
I found that.
Okay, so
but I didn't understand the square root of third. Like that didn't make any sense of how you plugged it into the equation.
Okay. All right. So first of all, to prove the area of an equilateral triangle. All right. This is two different problems. Okay. What does an equilateral triangle look like?
All the sides are equal, right?
Yes. Okay. All the sides are equal. So draw that. Okay, and if you remember, all right, in this equilateral triangle, it's a specialized isosceles triangle, right? So what's the height of that triangle you have there, Casey? Draw the height.
What, like a...
Yeah, draw the altitude for the height. Okay? And if you remember, because those two sides are equal, then it forms a right angle where it hits the base.
Oh, right.
Right? It's a right angle, and it cuts the base in half. Cuts the base in half. So that means each side on the bottom is s over 2. So write an s over 2 on one side. There you go. S over 2. And on the other side, s over 2. Okay? The side that's the hypotenuse is s. Right? So along the side of the triangle, write s.
Does it matter which side?
Well, no, well, both of them are the same, right? So you can put an s on the other side, too. Okay? So now, what's he done? What's happened? What has the altitude done to the bottom s? It's cut it into two pieces. Right? Now, how do you get using Pythagorean theorem, how do you get the length of the altitude? It's s squared minus s squared over 2, right? Because it's c squared minus b squared.
So it's
S squared, s squared minus s over 2 quantity squared. Put in parentheses, squared. All right, now let them see it. Now, isn't that how using Pythagorean formula to find the dotted line? All right. Now, how does that relate to Heron's formula? Right, is what you have to take the square root of both of those to be able to get the altitude. And you end up with that formula up there.
So that's a formula?
Yes, that's the formula. So what you have right there has to equal A.
Oh.
That's what, all right, and so that's how Heron's formula works.
Heron's formula is...
Write it down, write it down. You got it written down? Yeah.
The whole thing?
Yes.
Isn't it this? Wait.
Yeah. S, yeah. S minus A, all right, times S minus B, times S minus C, yeah. Where in this case, S is the perimeter of the triangle, right? And so in this case, S is the same as 3 times the round.
Oh. See, I didn't understand that at all.
Okay, all right. Okay, all right, now what about the second part?
Okay, I can do the second part.
Okay, all right, so do the second part.
Okay, the second part, isn't there a different formula for finding the area of quadrilaterals? To finding the area of regular triangles?
What'd you use?
Because I looked it up and it's, A equals the diagonal 1 times diagonal 2 divided by 2.
All right, okay, but you're gonna have to calculate the diagonal.
Yeah.
Okay.
Okay. Wait, do we want me to write one?
Yeah, draw your line. Where did you make your diagonals?
I thought the diagonals was just 7 and 8 because they were only diagonal lines.
They're not diagonals, they're on the outside. Diagonals are in the center.
See, that makes it a little different.
Okay, all right, go ahead. Right?
I don't, wait,
Okay.
no.
Write what you did do, and then, okay.
Why did I be all the way over here?
Yeah,
Write what I did do?
yeah, write what you did do.
So we can look at what I did
No,
wrong.
because I want to see the math of what you did.
Okay, I didn't do anything to this. I just did that
Okay.
formula. Wait,
Okay.
I did. So I did. And that equals 28. So the area equals 28. That's what I did.
Okay. All right, I said, so you got, okay. All right, so, all right, okay, so I see what you did. Put the diagonal from the top of 4 to the bottom of 3. Put the diagonal in there. All right, now, based on what we've already talked about, what Caitlin did, what's the length of that line you just did?
5.
Yes. So put the 5 there. Okay, now, it turns out that where the 5 and the 7 meet, that's a right angle. I think. Let's see.
Right there?
Yeah. No, other side.
Right there.
No, where the 5 and 7 meet.
Up there?
5 and 7.
I'm confused.
You see the 5? All right, take the 5 line, where does it meet the 7 line?
He already pointed to that.
Right there.
No, and he was on the inside of that. No, not there, on the other side of that.
Oh, the other side of the
Okay.
line.
Oh, wait.
No,
The
no.
other side of the 5, there's a right and there's a left.
Yeah.
On the right
On the right
side.
side.
On the right side of where the 5 meets the 7.
So wait, this is the
Where the
right.
5 meets the 7.
Oh.
Why am I so stupid?
No, just follow it. Don't be nervous. Follow it up.
I'm not nervous.
Follow it up.
This
Yeah,
line?
take it up. All right.
Up there.
No. Stay right where it meets. Now, on the right side.
Oh, that is right. Okay.
Oh, I see why. It was his right side he was doing. Okay, all right, thank you. Okay. Now, does that, what you wrote, is that going to be correct for a right triangle?
Yes.
How do you know?
I don't know.
All right, wait, well, is it a squared plus b squared equals c squared?
Yes.
All right, so what is a squared plus b squared?
What's A and B?
Well,
Three and four.
What in the triangle, in the 8, 7, 5 triangle, it has, okay.
Okay. So,
So-
it doesn't matter which one's A and B?
It doesn't matter, just as long as they're both.
So you do, wait, is this?
All right, now it does matter, because A is the hypotenuse, isn't it?
It
Look-
doesn't matter.
look-
So it's 7 squared.
7, okay, 7 squared. All right, because they're the two legs that make up the right angle, equals
8 squared.
8 squared. Now, is that going to be true?
No.
So therefore, that's not a right angle.
We take that away then.
Yeah,
We don't get that anymore.
okay.
So now.
So, all right, so what you're going to have to do is draw the line, the diagonal through the very center, Yeah.
That's
Okay.
7, 8, 9.
Okay, now if those are set up correctly, then you're going to have two triangles. And you're going to use 1/2 base times height.
So do I erase this one?
No, that has to be in there because that's the height. Isn't it?
Yes.
Okay. All right, that's part of it. Okay. All right, good. That's enough. That's enough because you've been under severe pressure. Okay. All right. If you would erase that. Okay.
I was
All right.
struggling.
That particular.
What? Why that was the only one that I know.
Okay.
Easy.
All
Why
right,
did
it was short. Herndon's formula is used when you know the perimeter of a triangle. That's where we use that the most. Okay, now my mouse is gone, so I'm still trying to find this stuff here. All right, now what do I need to do to get out of this? All right, come lower. There we go. All right, document 1, that's not what I want. Geometry lesson plans. There we go. Can I use this? No, it's not working. Here we go. Okay. All right, so we've done the projects. All right, the next thing that we're going to do is we're going to look at the quiz number 5, which you're going to take, and then we also, okay, here's what I've got to do. I've got to get to page 298, 1 through 5. Okay, now how do I do that? I go back to here. Text. All right, now. Okay, so here's the chapter review for this particular section. Okay, so this is chapter 7. if you had, oh, that's the algebra view. Why are we doing that? That's the wrong one, sorry. 97. That's not right. $289, $290. Okay. It's 90 instead of 80. Okay. All right, so here's what we want to look at here. All right, can you see those? All right, in the first, each picture find the geometric fact that is wrong. Okay, all right, in problem A, does that work as a right triangle? Look at problem A. How would you know whether or not that works as a right triangle?
A squared plus b squared. A squared times b squared equals c squared.
A squared plus b squared. So what's A and B in problem A?
5 and 8.
So it's 25 plus 64. Does 25 plus 64 equal 100?
No.
All right, therefore the angles are wrong. Or the sides, I'm sorry, not the angles. The sides are wrong. It does not meet the Pythagorean theorem. Okay, now B. This is the one Abby had. In a 30, 60, 90 right triangle, the 30-degree angle is half of what? The hypotenuse. Okay? So, in problem B, if you look at it, the 30-degree angle is 1. That means twice that, or 2, has to be the hypotenuse. Is it? Where's the hypotenuse located in a right triangle? So the hypotenuse is supposed to be opposite the top angle, which, what did they do? They switched the 2 and the square root of 3. You're in the wrong places. Because the hypotenuse in problem 2 is on the bottom, isn't it? So the 2 and the square root of 3 are in the wrong place. All right, now, in part C, this is an isosceles triangle. If you bring the altitude, because this is an isosceles triangle, if I bring the altitude down here, it meets at a right angle and it bisects that. What's it do with the base? It bisects the base, right? So now, what is the relationship between the side opposite the 30 and the hypotenuse? Abby, that was your problem. All right, what is the relationship over here? We said that this should have been 2, and this should have been square root of 3. Because the side opposite the 30, if you double it, you have the side of the hypotenuse. What's the side opposite the 30?
1. 4.
It's 2.
Wait.
It's 2 because the 30 is done through the altitude.
Oh, first I thought you were talking about the B still, and I was like,
okay, so this one here says, then what should the hypotenuse be? Double it.
4.
What is the hypotenuse?
5.
Then it can't be a right triangle. I mean, it can't be a 30, 60, 90 because if it's a 30, 60, 90, this is supposed to be 4 and this is supposed to be 2 times the square root of 3. All right, what do you see here? All right, let's try, will Pythagorean Theorem work?
Oh, wait, no. The largest side is larger than the other two sides combined.
Okay, so therefore, the triangle side theorem means that this doesn't work. So these two values have to be what? Greater than 9 to have a triangle.
But they're 8. So.
Okay, so therefore, all right, good. All right, E. What are the numbers?
3.5.
So Caitlin, what is it? What kind of triangle is it?
It's not equilateral. It's
No, it's a right.
triangle.
It's a right triangle, right? So can it have a 70-degree angle if it's a right triangle?
No. it's
No.
not supposed to.
Because the two sides, the two smaller sides, what happened? Where'd it go? God. There. All right, the two smaller sides. All right, Casey, you had this also. Remember when we had, all right, this right here is where the right angle is supposed to be. So it can't be 70 degrees. Because this is a 3, 4, 5 right triangle, and the value of the angle has legs of 3 and 4, so that's where the 90 is. All right, what about the last one?
It doesn't add up to 180.
It doesn't add up to 180. Okay, that's the type of thing that you've got to be able to identify. Okay, now let's go to K, because K is another skill. Remember the remote angle? Is this plus this adds up to how much?
180.
And all three of these add up to 180. That means this has to be the same as both of those.
And it's not.
And it's not. Okay? All right, now. I would guess that these two added up do not add up. All right, do this with your calculator. Put square root of 10 in your calculator. Oh, no, wait. No, it's a squared plus b squared. So this squared is 10. This squared is 3 plus 2. So 3 plus 2 does not equal. And you'll also find what I was going to do was that these two added together is less than this answer, is what I was about to do. But we could use, so let's do that. What is square root of 3 plus square root of 2? And then compare it to the square root of 10 in your calculator.
It's the same. Wait, no, it's half of 10.
No, wait, no. Do it with the calculator.
One day I'm gonna
Now
draw that
you're
line today.
All right. So we're going to compare this one.
They're different.
But the two added together is shorter than this, isn't it?
It is.
Okay, so therefore, just like this other one, where was the one here? That this one right here, that the triangle side theorem, these two have to add up to that one. Well, the same thing is true here, right? This length is 3 point something, right? 3.1, right? This is 3.1. This is 1.4, and this is 1.7 or thereabouts, isn't it? Something like that. I know this is 1.4, this is 1.7, and those two added together don't equal, or they're not big enough to be able to create a triangle. Look at this one. This distance here is 3. That one, I haven't figured that one out yet. Okay, all right. So let's move to the rest of this. All right, now, A certain equilateral triangle has an altitude of 6. Okay, if the altitude is 6, then this is where you have to do the equilateral triangle in reverse. Okay. If you have an equilateral triangle, this altitude makes this here 30 degrees. Okay, and the normal way you do that is this is 1, this is 2, and this is the square root of 3. Now, what they said was that if this is x, this is 2x, and this is x times the square root of 3. See how that goes? If this is x, this is 2x, and this is x times the square root of 3. Now, what they said was x times the square root of 3 equals 6, and they want to know what x is, so that we can find the area. All right, find the area. So, what does x equal? What do I have to do to get x by itself?
Isolate it. Or not. Nope.
All right, divided by square root of 3. And then if I rationalize this, right, this makes a regular 3, and 6 divided by 3 means that that's 2 square root of 3 is what x equals. So now I have this value and this value, and I want 1/2 the base times the height, which is square root of 3 times 2 square root of 3. Because this is the value of x, and this is x times square root of 3, which is that. All right, so how do you simplify that? 1/2 2 is 1, that cancels. What's 3 times square root of 3? 3 times, the square root of 3 times square root of 3 is a regular 3. Regular 3 times 2.
6.
So this becomes 6 square root of 3. That's the area. Now, that is a senior high school math problem. Because that takes all of the different skills for 30, 60, 90 right triangle and the area as well as Pythagorean Theorem to be able to figure all of that out. So that's all 3 different skills in that one problem. And it wasn't very long, was it? All right, so you see that? All right, so let's go back over that again because this is an important thing. All right, so equilateral triangle, right? We know what that is, right? So an equilateral triangle has all 3 sides the same. Therefore, the altitude here bisects this and forms a 30, 60, 90 right triangle. All right, now we're into what Abby showed us earlier, is that in the 30, 60, 90, the side opposite the 30 and the hypotenuse are in the relationship of 1 to 2. And the missing side is the square root of 3 times whatever that 30 side is. All right, so now I know that x times x square root of 3 times 1/2 is the area of that triangle, and I have 2 of them. All right, so the question is, if the altitude is 6, so if x square root of 3 equals 6, then that means that x is equal to the 6 divided by square root of 3, which I rationalize. That makes that a 3, and so that's 2 square root of 3. So if x is 2 square root of 3, then this becomes 2 square root of 3 times square root of 3, which is 6, and this becomes, well, we don't need that, because all I need is this. So if I have 2 of these, the whole length, this whole base is 4 square root of 3, 1/2, and then 6. And I'll end up with 12 square root of 3. So we've got 30, 60, 90, we've got the Pythagorean Theorem, and then we have the area of a triangle, all on the same problem. Okay. All right, next one. Find the area of triangle ABC. All right, this is a right triangle here, right? So if this is 2, this is 2, then this is 2 times square root of 2. Agree? That's an isosceles right triangle. All right, for 30, 60, 90, you have x, you have 2x, and then you have square root of 3 because there's 3 different sides, 3 different lengths. And then for this one, and I did it again. Isn't that weird? Okay, so now this, but what do you see here? That makes this 2 square root of 2. So the whole length of the base is that. So how do I find the area of this right triangle? It's 1/2 base times height. So it's 1/2 base times 2 plus 2 square root of 2. Well, this is 1, and so the answer is 2 plus 2 square root of 2. The right triangle has an hypotenuse of 14 and a leg of 8. Okay, hypotenuse of 14 and a leg of 8. I don't care where it is, let's put it here. Okay, what's this side? We got to take 14 squared and subtract 8 squared. Okay, 14 squared is what? 196?
It's 132.
132. So 132 is x squared, so it's the square root of 132. Get that? Now, how do you find the area, now that I've got that, how do you find the area of that right triangle? It's 1/2 which two numbers? Okay, look, 1/2 which two numbers? I want the area of this triangle. It's 1/2 base times height. So it's 1/2 which two numbers?
Square root of 132 and 8?
Yes, exactly. Exactly, all right? Okay, so 1/2, we can have 1/2 8 is 4, so it's 4 square root of 132. And that's probably not, that's not going to be a whole number, right? So it is what it is. All right, right angle has a hypotenuse. All right, that's what we just did, okay. Find A and B in each case. All right, AB is the length here. Wow. Okay, if this is an isosceles triangle here. If this is 60, this is 60. Right? Because the two 7s make an isosceles triangle, so the base numbers have to be both 60. Now, then what is this angle? Why is that 120? Because the two of them together make
180.
180. Okay, and then what is B as an angle?
It has to be 30.
It has to be 30. That makes this 7, doesn't it? Find the length of AB. You can't do that without, it's not a right angle. I don't know how to do that. I'm gonna have to find that. Anybody see something I don't? I'm missing something on that one. I wasn't ready for that.
What was it?
Well, again, we can get that this is an isosceles triangle here. Oh, no. Yeah, this is an isosceles triangle. Here it is. This altitude makes this a 60-degree angle because it bisects.
Came back.
Now what to do? Where'd it go? Here it is. Is that it?
Yeah.
Okay. All right, this is 60 because it's a base. That makes this 120. When this is 7, that makes this bisect. That's a 60-degree angle, and this is a 30-degree angle. All right, so here's my right triangle. What do you know about a 30 and a hypotenuse in a 30, 60, 90? That the short side opposite is how much? Half. Okay, so if this is the hypotenuse, this is 7 over 2, and this is 7 over 2 times the square root of 3. And there's one here and there's one here. So that makes AB equal to 7 square root of 3. Because there's two 7 over 2s. And together you get a full 7. Now that one, now that I see that's an isosceles triangle, then that's doable. Okay, what's the missing side for C up there? How would you find it? How would you find the missing side for C? What's the... No, what's all 4 total? What are all 4 of those angles going to total? 1 triangle totals how much?
180.
180. How many triangles will you have in a quadrilateral? 2. So what's the total going to be?
360.
And they've given you 3 of them, so you can find the 4th. Okay, so what will angle C be?
300? That's not right.
360 minus 130 minus 80 minus 90. Isn't it 60?
This calculator is weird. I don't understand. I'm putting it as language on the board.
Isn't it 60? A to B is a diagonal. Okay. so I'm going to send you the chapter 7.
Chapter 6 test.
Chapter 6 test. So, yeah, no, I'm going to collect 6. I'm going to send you chapter 7.
Yes, I have 6 with me.
Yeah, you're supposed to. Yeah. Okay.